Yeah, let's see some stuff that looks like your homework. So I've gone through, took a look, and this is going to be the instructions for you. These three pieces. You got a few of them. We're just going to ask you to kind of sketch the curve. Of course, you're just going to get some options and show its orientation. Uh, then you're going to want to eliminate the parameter and write the resulting rectangular equation. That was the last thing I did in the last video. We'll talk about that. And then we're going to adjust the domain of the regular equation. Or rectangular, my bad. Now I don't like the order in which they ask you to do this. I would rather do this. Call this 1, 1, call this 2, and then call this 1, 3. That's my choice. But you find your own way. Because I don't want to make a table every time. That bothers me. You can always make a table to sketch the curve and show its orientation. You could do that first. So if you don't like the way I'm doing it, that's cool. Go back to the first video I made and watch how I did it, and you can do all your problems like that. But you're going to need to do what I have highlighted as 1. You're also going to need to eliminate the parameter at some point in time. So I find if you have a basic knowledge of what some graphs look like parabolas or the square root function, just basic parent functions that we should have seen about 1,000 times in our algebra classes or our IM classes, then maybe we can graph this a little quicker. So I'm going to give you an example of this, and here's a good question. Similar to something you have in your homework. X is equal to t plus 2, and y is equal to the square root of t. Now again, we can make a table. I just don't want to. I don't want to. I want to eliminate the parameter and write the resulting rectangular equation first. Okay. All right, so the question's asking us to graph this thing up, but I'm like, nah, let's go aside. Let's kind of take a look at this and say, you know what they both have in common? They both have a t. They both have that t. So what if, don't mess with the one with roots or squares or any of that crap. Find the linear one. Notice there's nothing squared. There's no square roots. That's a simple one for us to go and solve. So let's go aside and say that x is equal to that t plus 2, and let's solve for t. And that's as tough as just subtract the 2 over, and we can say that t is equal to x minus 2. Well, shit. Don't we have that y is equal to the square root of t? Replace that in. And what we find out is y is equal to the square root of x minus 2. Now, I'm not sure if you've taken a college algebra class or anything like that where you actually had to do transformations, but this is a graph that we should all be able to graph. You've taken an algebra course, which means you should be able to graph a square root function pretty simply. Now, what ends up happening here is we have some domain restrictions as well. Now, you could plot some points and graph it, but I'm just going to give you the basic square root function, y equals the square root of x. It looks like this. It's almost like a parabola on its side, but we're not allowed to have anything down in the negative y values. I'll let you look that one up. But what this does, if you haven't learned any transformations, is this is going to shift everything to the right by 2. So the way this graph is going to turn out is right here at 2 is where we're going to start. And it's going to go a little something like that. Now you could have made a table. First, plotted all your points, plugged them in. But where are you going to start with your values of t? Where were you going to begin? Because there's no values given here. It's just saying graph it. Just graph it. Do you see any issues? Do you know what direction it goes? Can it keep going on forever? Well, we got to do a little bit of an exploration. We got to take a look and go, well, hold up a second. Hold up. Do you think there's any values of x's that might be bad? You think I could plug in 0? The square root of -2. Is that going to work? Of course not. Of course not. That can't work. You can't have the square root of -2. You can't plug that in. Look, you can see by the graph, there's no x values that are stuck over here. There's no x values that are stuck over here. So, let me recap. There was that first thing we were supposed to do. Here's the second thing we were supposed to do. And the third thing is just asking us, what's the domain of our rectangular function? Look at the graph. X's have to do with the domain. There's nothing over here. So we would say that the domain of our function is, you can plug any x value you want to as long as it's 2 or larger. And there's that third part. Now, I've done everything, but I you know what? I'd get an 80% on this test. If this was a problem on a test, I'd only get 80% because I forgot to do something. I forgot to put in orientation. Shoot. I forgot to plug in my orientation. You know what I mean? I got to tell you, is it going this way? Or is it going this way? I'm guessing you can probably tell. But how are we going to figure that out? How are we going to know? Come right back here. Just plug a value of t in. You're going to plug in t equals -1 first? Plug that in underneath the square root? Of course not. You can't have a negative underneath the square root. What could you start with? What's the smallest number that you can take a square root of? 0. 0. So what happens? What do we get when we plug in t equals 0? And this is the table I make. I'm just going to look and see where the frick do we start? And we start at, so we plug this in and we go, our x value is going to be 2, right? Because 0 plus 2 is, and then we're going to say, oh, plug it into there. What's the square root of 0? 0. So it's saying we're going to start right here. So where the hell do you think we're going to go? We're moving in this direction, and there's the orientation. Plug in 1, you're going to find out you get 3, 1. You plug in t equals 1, you find out that you get 3, 1. So clearly we must be doing one of these. All right, we're moving in that direction. Now we've given it the orientation. We've also gotten a rectangular equation, and we know the domain of the function. All of a sudden, this class is starting to let you know, do you know your algebra? Do you know your graphs? Do you know how to solve and move stuff around? Because the majority of this class has been minimal algebra. Now, this class is trying to get you ready for physics, which uses a ton of algebra. It's trying to get you ready for calculus, which is pretty much dominated by algebra. This is getting us ready for that next. So if this is feeling like a lot, and you're planning to go into a Calc 1 class, and this sort of algebra is rough, you might want to consider taking a pre-calculus class before just jumping on into there. Or you get your practice here, jump right in, show what a badass you are, either way. All right, so we'll be back with some actual ones with some trig in it, maybe some sines and some cosines for the next. I know I jumped around a lot on this one. I'll try and make the next one a little bit more streamlined. All right, see you.